Hey everyone, and welcome to our deep dive all about carbon capture technology. It's interesting how we're kind of looking at fossil fuels as this double-edged sword, right? We
Yeah.
might still need them for a while, but we also know they're not helping climate change. And that's where this carbon capture technology comes in. And get this, some sources say it can actually capture over 90% of the CO2 emissions from power plants and factories. Talk about a game changer.
Yeah, for sure. It'll take a while to transition to only renewable energy. So in the meantime, this carbon capture tech can really help lower emissions.
Yeah, it really is like a secret weapon in the fight against climate change.
Yeah.
But before we get too excited, I think we got to understand what exactly IS this technology and how does it even work?
Good point. So carbon capture technology, or CCT, it basically means capturing CO2 from places like power plants and factories before it can get into the atmosphere. Then that CO2 is moved and stored somewhere safe, usually deep underground.
So it's like we're stopping the emissions right at the source and then putting them in a safe spot, kind of like a super high-tech waste management system for CO2.
Yeah, that's a great way to put it. And what's really interesting is there are different ways to capture CO2. It's not like a one-size-fits-all kind of thing.
Oh, okay. So tell me more about that. What kind of different methods are we talking about here?
Well, there are three main types of carbon capture. You've got pre-combustion capture, post-combustion capture, and oxy-fuel capture. And each of those has its own strengths and weaknesses, so they're suited for different applications.
Got it. So it's like having different tools for different jobs. Let's break those down a bit further. What's this pre-combustion capture all about?
Pre-combustion capture is all about capturing the CO2 before you even burn the fuel. It's especially useful for a certain type of power plant called an integrated gasification combined cycle plant.
So we're literally stopping the emissions before they can even form. That's pretty impressive. What about post-combustion capture?
Post-combustion capture, like the name suggests, is removing the CO2 from the flue gas after combustion has happened. This one is often used to retrofit existing power plants.
So it's like adding a filter to power plants that are already running. Makes sense. And what about oxy-fuel capture? What makes that one special?
Oxy-fuel capture is interesting because it involves burning the fuel,
Mhm.
but you burn it in pure oxygen, and that creates an exhaust that's mostly CO2, which makes it much easier to capture.
So each method has its own unique approach. It sounds like scientists are getting really clever with these techniques. Like a whole world of possibilities is opening up.
For sure. And we can't forget about nature's role in carbon capture. Like trees, for example, they're natural carbon capture
Oh
champions.
yeah, trees are awesome. They just suck up the CO2 during photosynthesis
Mm,
and then store all that carbon in their wood and roots. It's like they're always cleaning the air for us.
exactly.
Hmm.
And there are ways we can help them out even more. Like there's a technique called enhanced rock weathering, where you spread crushed rocks like the salt onto the soil.
Wait, so rocks can help fight climate change? That's a new one for me.
It's true. These rocks just naturally absorb CO2. And as a bonus, it improves soil fertility.
So it's a win-win for the environment. A&D agriculture, that's amazing. But it sounds like we're not just limited to trees and rocks. What about those high-tech solutions I keep hearing about?
You're right. There's some really incredible technology being developed, like direct air capture, or DAC, which literally sucks CO2 right out of the air.
Wow, straight from the air. That sounds like something straight out of science fiction. How does that even work?
It uses these big fans to pull in air, and then it passes that air through special filters that can actually capture CO2 molecules.
So it's like we're building giant air purifiers for the whole planet. That's incredible. I also saw something about cryogenic carbon capture. Is that similar to DAC?
No, cryogenic carbon capture is a bit different. It uses really, really cold temperatures to freeze out the CO2 so it separates from other gases.
So it's like a high-tech way of separating ice from water. But instead of water, we're dealing with CO2. Pretty clever. And what about nanotechnology? I've heard that's being used for carbon capture too.
Nanotechnology is really exciting. It involves using these tiny materials with a huge surface area to capture and store CO2. And these nanomaterials can actually grab CO2 molecules at much lower pressures, which makes the whole process more efficient.
It's mind-blowing to think that we can manipulate things at such a tiny scale. To tackle a problem as big as climate change, it feels like we're entering a whole new era of carbon capture, with all these incredible technologies pushing the limits of what's possible.
Absolutely. And as research and development continues, we can expect even more innovative and effective solutions to come out in the future.
Okay, so we've got trees and rocks doing their thing, and then we've got this whole arsenal of high-tech solutions, like direct air capture, cryogenic capture, and nanotechnology. That's a pretty impressive toolbox.
It is. And remember, this technology is always evolving, so it's a super exciting time to be following all the developments.
For sure. Well, this has been an awesome overview of the different types of carbon capture tech out there. I'm already feeling way more informed.
Great, I'm glad to hear that.
We've covered a lot of ground, but there's still so much more to explore.
Definitely. We haven't even gone into the specifics of how these technologies work or the challenges they face.
And I'm curious to learn more about how carbon capture is actually being used in the real world.
There are some fascinating examples of carbon capture projects all over the world, from power plants to industrial facilities.
Well, it sounds like we have a lot more to talk about.
We do, and I think our listeners will be surprised by some of the innovations happening in this field.
I'm sure they will. Stay tuned, everyone. We'll be right back after a quick break.
Welcome back to our deep dive into carbon capture technology. Before the break, we were talking about all the exciting ways we can capture carbon dioxide and stop it from getting into the atmosphere. We talked about the three main types of carbon capture: pre-combustion, post-combustion, and oxy-fuel combustion. Let's dig into those a bit more, starting with pre-combustion capture.
All right, pre-combustion capture. The one that tackles CO2 before it's even formed. Sounds kind of like magic. Remind me again how that one works.
It's all about chemistry. Remember those integrated gasification combined cycle plants we mentioned? They convert the fuel into this gas mixture, and that mixture contains carbon monoxide. So in pre-combustion capture, we do something called a shift reaction. It's basically a fancy chemical process that turns that carbon monoxide into CO2.
So we're kind of like forcing the CO2 to reveal itself early on.
Yeah, that's a good way to think about it. Once we have this concentrated stream of CO2, it's way easier to separate it and capture it, usually by using a special solvent. That attracts the CO2 and pulls it away.
So it's like we're separating the good stuff from the bad stuff.
Mm.
But in this case, the good stuff is actually the harmful CO2 we're trying to get rid of.
Exactly. This captured CO2 can then be transported and stored safely, while the rest of the gas, which is rich in hydrogen, can be used to generate clean energy.
So we're stopping CO2 emissions, A&D, making clean energy all at the same time. Two birds, one stone. That's awesome. Okay, what about post-combustion capture? How does that one work?
Post-combustion capture is more about cleaning up after the fact. It captures the CO2 from the flue gas, which is the mixture of gases that's released after the fuel has been burned.
So it's like adding a filter to the exhaust pipe of a car.
Yeah, that's a good analogy. In this case, the filter is a chemical solvent that grabs onto the CO2 in the flue gas, separating it from the other gases. Then the CO2 is released from the solvent, and the solvent can be used again to capture more CO2.
It's amazing how scientists have figured out how to use these chemical reactions to target and capture specific molecules like CO2. But now remind me about that third type, oxy-fuel combustion.
Oxy-fuel combustion is like burning the fuel in a really controlled environment. Instead of burning the fuel in air, which is mostly nitrogen, we burn it in pure oxygen.
And why does that matter?
It makes a huge difference. When you burn fuel in pure oxygen, the exhaust is mostly just CO2 and water vapor, and the water vapor can easily be condensed out, which leaves us with almost pure CO2, ready to be captured.
So it's like we're making the whole capture process way more efficient. No need for all those complex separation techniques.
Yeah.
That's pretty cool.
Exactly. Oxy-fuel combustion is a pretty simple method, and it's looking really promising for new power plants.
So we've got these three main approaches to capturing CO2, pre-combustion, post-combustion, and oxy-fuel combustion. Each one has its own advantages. And it seems like they each have their own perfect fit for different situations.
Exactly. The best technology to use depends on a lot of things, like what kind of power plant or factory it is, how much CO2 is in the exhaust gas, and how much it costs to implement.
It's like having a toolbox full of specialized tools for all these different carbon capturing jobs. Now, I'm really curious about those super advanced technologies we mentioned earlier, like direct air capture and nanotechnology. Let's dive into those.
Okay, so we talked about those three main types of carbon capture: pre-combustion, post-combustion, and oxy-fuel combustion. But then there's like this whole other category of carbon capture technology that's almost futuristic, stuff like direct air capture and nanotechnology. Let's talk more about those.
Yeah, those technologies are really pushing the boundaries. Direct air capture, or DC, is super interesting. It's like having these giant air filters for the whole planet, pulling CO2 straight out of the atmosphere.
Yeah, it's crazy when you really think about it, but how does it actually work? Are we talking like massive vacuum cleaners sucking in air?
Well, not exactly vacuum cleaners, but kind of similar. DC systems use these big fans to pull in air, and then that air goes through these special filters or absorbers, and these materials are designed to like chemically bind with CO2 molecules. So they basically trap the CO2. So it's like a giant chemistry experiment.
Yeah.
But on a planetary scale, what happens to the CO2 after it's captured?
Once the filters are full of CO2, the system switches to a regeneration mode, and that's where the CO2 is released. But this time, it's in a concentrated form. Then that pure CO2 can be transported and stored underground, just like with those other capture methods.
It's amazing how they figured out how to create materials
Yeah.
that can actually target and capture those CO2 molecules
Right.
from all the other gases in the air. It's like a high-tech game of molecular hide and seek.
It really is. And D-dye has so many potential uses. Like, it could be used to offset emissions from industries that are hard to decarbonize, like aviation or some heady
So it's
industries.
like a safety net for those hard to get rid of emissions. That's
Yeah.
really cool. Okay, now what about that cryogenic carbon capture method we talked about? How does extreme cold actually help with capturing CO2?
Cryogenic carbon capture, or CCC, uses the fact that different gases freeze at different temperatures. So by cooling down a gas mixture to super low temperatures, we can basically freeze out the CO2, while the other gases stay as gases.
So it's like making CO2 snowflakes.
Exactly. And then that frozen CO2 can be collected and separated from the other gases. It's a fairly simple method, and it works really well when there's a lot of CO2 in the exhaust gas.
Okay, last but not least, let's talk about nanotechnology and carbon capture. I always think of tiny robots when I hear about nanotech.
Well, it's not quite robots, but the idea of manipulating things at such a small scale is pretty mind-blowing. For carbon capture, we're using nanomaterials, which are materials with these incredibly tiny structures to capture and store CO2.
So how do these nano-sized materials make a difference?
Nanomaterials have a really high surface area compared to their volume. Think of it like a sponge. The more surface area a sponge has, the more water it can absorb. It's the same with nanomaterials. More surface area means they can bind with more CO2 molecules.
So it's like having millions of tiny CO2 magnets all working together to trap those emissions. And you mentioned that nanotechnology can actually make the capture process more efficient.
Right. One of the cool things about nanomaterials is that they can capture CO2 at much lower pressures than traditional methods, so the whole process needs less energy, which makes it more efficient and potentially cheaper.
It's amazing how such tiny things can have such a huge impact. It feels like we're just scratching the surface of what nanotechnology can do for carbon capture.
Definitely. As research continues in nanomaterials, we can expect to see even more innovative and efficient solutions in the future.
Well, I think we've covered a ton of information today. We started with the basics of carbon capture, then went through those three main types, and finally dove into the world of direct air capture, cryogenic carbon capture, and nanotechnology. It's really incredible how science and innovation are helping us find solutions for a cleaner future.
It's definitely inspiring to see all the progress being made, and it's important to remember that carbon capture technology, while it's not a perfect solution, is a really important tool in the fight against climate change.
Absolutely. It's all about having lots of different tools, exploring all the options, and pushing the boundaries of what's possible. Who knows what other amazing discoveries are out there waiting for us?
I can't wait to find out. Thanks for joining us on this deep dive into carbon capture technology.
And it's been a fascinating journey. And to everyone listening out there, keep learning, keep exploring, and stay curious about the world around you. We'll catch you next time on the Deep Dive.